Hey everyone, welcome to the fifth episode of the Coffee with Cosmos DB series. Before we kickstart, a couple of announcements. If you're joining this live session for the first time, this series is all about spreading the knowledge on Cosmos DB by experts to the community. So please make sure to subscribe this channel and share the link with the community members who are looking to learn about Cosmos DB. So if you're interested to present or have any feedback, feel free to reach out to me. And thanks for all the feedback so far. Another exciting announcement is that we have the Cosmos DB Conf coming up in a week's time. So please register or block your calendar for 3 hours of awesome live content. With that, let me introduce our guest for today. Let me add him to the stage. Hey, Avijit, how are you doing?
Hey Saji, I'm doing good. How are you?
Yeah, doing well. Thanks for asking. Yeah, so uh, uh, Avijit, why don't you go ahead and introduce yourself?
Sure. So my name is Avijit, and I am the senior program manager on Azure Cosmos DB for Postgres. My primary focus has been into the improvising the telemetry health and looking at the monitoring bits of the product. And I have been engaging with some of the customers in APAC region as well to help them onboard to the service. So yeah, that's the brief about me.
Got it. Yeah, regarding today's topic, I know everyone is excited on today's topic. We have been talking a lot on this earlier between us, I mean, even at work, but it's a time to unwrap and talk about the architecture of Cosmos DB for PostgreSQL who are watching this session, right? So we got an exciting topic to discuss on. Just to give a glimpse about it, last year we made an announcement of Cosmos DB for PostgreSQL, a newly generally available service to build cloud native relational applications. And Azure is the only cloud provider to offer its own single database service that supports both relational and NoSQL workloads. Today, Avijit will cover about the technical architecture of Cosmos DB for PostgreSQL. Let's jump to the discussion. Avijit, I know you got some slides to share. Please proceed and stage is yours. I will try to interrupt when I have questions.
Sure. Feel free to interject wherever you feel like asking a question, and I'll be happy to help.
Yep.
So let me go ahead and share my screen. I hope that my screen is visible now.
Yep, can see.
Understood. Let me. All right. So before even getting into the technical deep dive thing, first thing that I would like to provide as a background about the product is that this product is not new and has been existing in the market even previously, just that there has been a rebranding back in October month where it was like reintroduced as your Cosmos DB PostgreSQL API, and there are good reasons to do that. I'll be covering some of it as we talk further during this discussion. So yeah, let me first start with a brief history on the evolution of distributed, like how did we reach to distributed SQL state, and what made us come to this stage, right? So uh, to start with, like we kind of like we are all aware that uh, we had the relational databases for a very long time, kind of like since 1990s. For a couple of decades we have been using it, and that has been like extensively used in across all the kind of different industries, right? And primarily the reason being the steadiness that it provided, and the benefit of the ecosystem, as well as the great support that was available in the community, right? But during, like as we move towards 2008-ish time frame, like somewhere around 2010, we observed that there was like newer application coming into the emergence, right? And the core requirement for these application was very different. Like they were looking after the scale, they were looking for higher performance than a single node could possibly offer. And then uh, drastically changing schemas were one of the other factors which was like highly required by these applications. Although one of the things which kind of like was not so important was the consistency of this data. So we saw NoSQL databases like were built which were like very specific to these use cases, and were like uh, very heavily supporting and helping these applications to go very fast, right? Now, as we are moving, like as we move toward 2020s and later, we are observing that same kind of pressure is being like observed, where customers are looking into convergence of the benefits that we are getting from the two platforms, right? One, the ACID guarantees that is being offered by the relational databases, while still thinking about scale of these, like horizontally scaling portion of the NoSQL databases. So when here exactly, like we see Azure Cosmos DB for PostgreSQL fitting well into the situation where it kind of like guarantees you the ACID benefits and lot more things, the comprehensive of the SQL language and the other benefits of joins and foreign keys, right? While it is a horizontally scalable solution. So that's the beauty about it. Uh, so let me like first move forward and talk a bit more about this distributed nature, which is like um, what exactly do we mean by distributed PostgreSQL, right? And like from the history, everybody kind of like knows that and probably can imagine a single Postgres node, uh, which is offered as a managed offering or a service in cloud, and has an endpoint and a port exposed to the application, where application like sends in the request, right? With several other benefits of the cloud, which is kind of like providing the inbuilt backup and resource solution, helping them with the HA solution, the maintenance bits of things, and even on demand vertical scaling. So all of that being provided inbuilt as a managed benefit, right? Uh, so all of this is all still being served on Azure Cosmos DB for Postgres as a single node offering. But the differentiation lies in the capability of this platform to be able to do the distribution of this data, like sharding and splitting of the data across the cluster of nodes, while still hiding the complexity behind the scenes, like the distribution of data that happens underneath, right? So for the application, what does it look like? It is still, there is a head node. We call it as coordinator. So effectively, your application will still have a single endpoint to talk with, and coordinator, the head node has the metadata information and all the details, and it is able to like make decisions around like either scoping the queries or like fanning out the queries and being able to like serve for all the requests that comes in. So kind of like helps with the scalability as well. So
Got it. Okay. Yeah, thanks for setting up the context and taking us through the history and about distributed PostgreSQL. I got a question. So you spoke about single node, right? Can we start with a single node setup on Azure Cosmos DB for PG and then later scale it up to multi-node setup, and whether that would require the customers to change anything on their side? Any guidance on that would be great.
sure. So I'll take this as two parts. So number one is, can we move from a single node, like can we start with a single node and then as we require, can we scale it up to multi-node setup, right? And second one being, whether will that require us to take a downtime, or whether that will require you to change anything on the application side, right? On the first part, like we effectively intend to provide the solution, as in like uh, customers should not even have a challenge or have this thought of having a bottleneck around horizontally scaling the solution. That's kind of inbuilt. So we would like ideally a customer to be able to like start very small, like start with a single node. But while trying to do that, just keep that in mind that considering your future growth, the data model should be able to cater to the requirements in future. Something like you should have distribution key as part of this data structure that you're creating, right? So that when you have a need of moving from a single node to a multi-node setup, then you can effectively just utilize this key and shard the data using that common key, right? So that's like the core of it, which is you can move from a single node to multi-node, and that doesn't require you to make a lot of changes effectively, until and unless you are taking care of the data model initially in the cycle where you have the distribution key. In case you don't have it, then definitely you will require making some changes to the application and the data structure as well, because you are moving from a single node setup to a multi-node setup. So you are requiring sharding this a single table and putting it up on different nodes in the cluster. So
Got it.
that will require you to define a distribution key, and that's kind of a bottleneck, right? So if we take care of it early in the cycle, then that will be handled.
Got it. Thanks, and it makes sense. So, and a great explanation as well. I have further question associated with that, but you already covered whether that requires downtime. My next question, right? You mentioned about evolution of databases and convergence of NoSQL and SQL as it benefits. How does this do in terms of compatibility to PostgreSQL ecosystem as together? Yeah.
So talking about the compatibility, I think we are a true Postgres solution. So uh, we offer almost everything that is served by the PostgreSQL community. The best part, or the way I would like, I think uh, I should talk a little more about this, which is like Azure Cosmos DB for PG is built over a open source community Postgres solution, right? And it is built over open source Citus, like it uses open source Citus. And Citus is kind of it's an open source extension which solves for the horizontal scalability of Postgres system. So it's the development is happening over the community version of it as an extension, and it's not a fork of what exists in Postgres, right? That's part one. And other things regarding the ecosystem. So the different application, the clients that we are using, the drivers we are using to connect with the community Postgres database, that will still work out of the box with Azure Cosmos DB for Postgres. So there is no restriction in those senses as well. Apart from that, it also has support for kind of 50 plus Postgres other extensions, like they are completely compatible with Citus. And these are kind of like very commonly used across the industry, like something like for geographical data sets, it's kind of like using PostGIS extension. For troubleshooting, we are using pgstat statements. Then there is other HLL and top end kind of different extensions that are being offered on the platform itself. So these can be used alongside Citus. Other than that, I think one other piece that I would also like to cover is that the SQL bit of it, like the relational bit of things. So I think I covered this even during the evaluation, like when I was talking about the convergence of things. But I want to reiterate this, that the although this product happens to be a distributed Postgres solution, but it still offers for the ACID guarantees being offered by a single node setup. Plus, it does support the primary keys and foreign keys and other constraints, all joins and aggregations. All of that is still supported on the platform. And apart from that, the different data types which exist for the community Postgres version of it, all kind of are supported on the platform. So yeah, that like completely gives you a picture of why do we call it as a true Postgres solution. Like uh, it kind of like completely I would say merges into the ecosystem of Postgres. So there aren't any special requirements around this. So
Got it.
does that like help you
Yeah,
uh, clearly understand?
definitely.
Okay, thank you. So I'll just move on to the main piece, which is the technical architecture. So effectively, this is how the HA setup would look like. In this setup, we can see there are two special kind of nodes, right? We can see a coordinator lying there, and then there is a worker node. So coordinator is something we call it as a special node, which has the metadata information about the actual customer data. So coordinator is not supposed to contain any data on a multi-node setup. And the worker nodes in itself are the ones which actually contains the user data. So effectively, your split of data will happen across these nodes. And one worker node can of course have multiple shards, and then each shard can further have many other distribution keys in itself. So that kind of opens up, or like provides a detailing around insights about the shards and their existence on the worker nodes, right? Other thing that I would like to other thing that we can see on the screen is application just talking to the coordinator. So that's effectively one of the pieces which I talked about previously as well, is that for the Postgres application, it doesn't, or the client, it doesn't have to know about what's happening in the background. It still abstracts your complexity. It just talks to one single node, and that special coordinator node is able to take care of all the requests, like either it's to do with the scoping of query or fanning out the query, doing a group by or such kind of operations, right? Apart from that, in this setup, we can see that there is an AZ1 and AZ2 setup. So effectively, AZ1 represents your primary cluster, AZ2 is your secondary cluster. And if there is a situation of a failover or DR, then you can effectively failover from AZ1 to AZ2 without losing any data. And that's transparent and automatic. Other than that, I think each individual worker nodes has a logical replication setup between them, and failing of one worker node would just result in failing of that data set. Like it won't have the data available on worker node 0. So it just takes the failover time to do replacement of worker node 0, but there will be no effect on rest of the data sets in the system. It will continue to serve for rest of the worker data on the other worker nodes. Apart from that, the horizontal scalability bit, the vertical scalability and horizontal scalability bit. So we can scale the coordinator independent of the worker nodes, and we can also scale the individual worker nodes independent of the coordinator. So all of these, like worker node as a group, will be scaled and they will be of same configuration, while coordinator could be of a different setup configuration as well. And this is about the vertical scaling bit of things. And of course, storage can be separately increased or brought down. No, not brought down, rather once increased, it cannot be brought down. So storage is another bit of it. And then you can always do a scale out operation as well, which is like adding more worker nodes to the setup. By adding a new worker node, you will automatically have the another worker node standby created in the background if it is HA setup. So you don't have to take a special care of that. And once you add a new worker node in the setup, that wouldn't result in any data movement, right? So for actually doing the rebalancing of data set, there are internal functions that we have, like Citus provides to the consumer, to the customer, right? So effectively what you have to do is you have to trigger these functions, which kind of like understands the strategy, like by default it's on the shard count, but yeah, you can choose to go with the disk size as well as your own defined strategy based on UDFs. So you can create a user defined function and then define your own strategy in terms of like how do you want to keep the data split across the cluster. Um,
Yeah,
yeah.
I got a question, right? I see that you have listed logical partitioning for high availability setup. Are there different partitioning methods offered within Postgres, or is there a specific reason for choosing logical partitioning? I hope
Okay.
that
So
question is
yeah,
clear.
question is clear to me. Yeah. So your question is about like why are we choosing logical replication, and are there any alternatives? Like why didn't we go with any other thing?
Yeah.
So Postgres does offer like two different kind of replications. It has physical and logical replication. And just because we are talking about it, I'll also add that replicas are actually synced through the physical replication bit, while all these HA nodes are actually synced through the logical replication bit. And reasoning behind like physical, when we talk about physical replication, the core requirement of the system is that it requires source and destination nodes or systems to be exactly alike. So they have to be of same configurations, the same Postgres version and all of that. But when we talk about logical replication, that flexibility is there, that it can actually do replicate with different versions of things and different scale of like different configuration between the two servers, source and destination. In our case, because we use the high availability node in for multiple reasons, like whenever we do a critical patching, or whenever we have to upgrade, like do a major upgrade of the system, or whether we are doing with, like, let's say, scale up or scale down operation, right? In those cases, to reduce the downtime, what we do is we perform the in place upgrade of standbys, and post that is completed, we do a failover. So effectively, your standby, it's just the failover time which is accounted as a downtime, and then your system is like upgraded from, let's say, 4 core to 8 core, or whatever you chose to be, right? So that's kind of like the reasoning behind choosing the logical replication, because uh, you are often changing the destination while your source is still the same.
Got it. I guess you clearly explained the different aspects on the architecture. From the general distributed system architecture perspective and from the SaaS lens, right? I have one more question. How do we handle cross-shard queries, and if this has any impact to the performance of the application? Can you?
Sure.
Yeah,
Yeah, I think that's the sweet spot. So I would say, our application, rather, typically what we see is there are two different kind of use cases, where it's either going towards the analytics side of things, or it is going towards the SaaS or OLTP side of things, right? Since you talked about SaaS application, like multi-tenant SaaS stuff, it's more like in those situations, what we see is typically your individual tenants data will be spread across different shards, and these shards will lie on different worker nodes, right? So if you're querying the data based on, let's say, the tenant key or the distribution key, your coordinator has that metadata information that it routes the query or scopes the query to a particular worker node. So effectively, you are still routing that query to like, it is kind of like optimizing the usage of resources by just routing or putting the query on a single worker node. But there could be situations where, like, when we talk about tenants, they will just try to query their own data. But when we talk about the landlord, which is exposing their service to these tenants, right, they may want to know, like, what has been the scale of things, like how our different tenants are doing, what kind of scale are they going in, or different kind of analysis, right? Which could be a fan out query as well. Effectively, what they will do is, across these worker nodes, they will want to know, okay, what's the total data size for each of these data, like each of our tenants that are hosted on the platform, or which one is the largest one, right? In those cases, what it has to do is, it has to do an aggregate query, a group by query, and these will be like a fan out query, which will, like, uh, coordinator would understand, okay, it has to check all the tenants for a specific data requirement. It tries to query that and gets that data from different shards and worker nodes to the coordinator. Once that is there, it finally like refines it to the state and then sends it back to the application. So effectively, your parallelization helps in this case, while in case of like a single tenant query, it is still going to a particular node.
got it.
Other bit, which is like, I because I still didn't answer your cross shard thing. So it is more about like co-location of things, right? So if we talk about joins, there could be multiple tables with different shards. There could be queries which are hitting those two shards. The important thing is, if these happen to be on the same worker node, then it's still going to be a performant thing. So but and that is where like the concept of co-location comes in. What we do is, we distribute the tables which are like being joined together, like across the queries. What we try to do is, we try to co-locate them on a common entity or a common worker node, so that similar data, like for one tenant data, if there are, let's say, four tables, all these four tables for this tenant data will all lie on a single worker node. So you will be able to do the joins efficiently by keeping the scope within that particular node, and still being able to like still remain performant about it. You The cross node queries is what would have hurt us. So that's something we try to completely avoid in most of the situations. But even if that situation arises, the situation where I talked about landlord, it would effectively do it in parallel, and the queries will still be local to those worker nodes and aggregated finally at the coordinator and sent back to the application. So that ways, in all the situations, we are kind of like choosing, picking, and improvising on utilization of resources, and like helping the system to remain performant.
Got it. Thanks, Avijit. I guess we are on time, but a final question, right? For a beginner, like, what are the things that you explain how they can get started on, our Azure portal? Can you go through that?
Sure. Let me like go to the portal and quickly show how can we do the provisioning of Azure Cosmos DB for Postgres. Something odd going on with my system. Let me retry.
Sure.
And
This always happens in live demos, right? So that's expected.
yeah, luckily for me, like it worked just now. So, okay. So let's say we are trying to provision a resource on Azure Cosmos DB, right? And of course, this is our API. Let's say on the portal, you'll just search for Azure Cosmos DB. Now click on this service, Azure Cosmos DB, and you'll find you'll do a create resource here, and now you'll land to this page where you'll see different options available. Like you can choose to go with different NoSQL offerings are here, and then here is this PostgreSQL what we would like to provision here. So let's click on create. Now there is a common form kind of similar to what is being asked in other APIs as well, like subscription details, resource group details, and then provide a unique name to your cluster. But the point where I would like to focus here is that this configure, like scale blade. So as I was talking previously about things, so there is a single node setup. As we can see at the moment, there is just one node, which is showing as coordinator plus worker, right? And it kind of like gives you different configurations. You can scale up to a machine which is 64 vCores and to 56 GBs of RAM and a storage of 512. Although this can be scaled up to 16 terabytes from backend. So that's the thing. And apart from that single node offering, what we can do is we can also choose to go with a multi-node setup, which is, let's say, if I go with 3-node setup, right? What we can see now is that there is a coordinator existing here, and then there are 3 different worker nodes created, right? Uh, that will be created or provisioned. So we can see 2 different configuration here. One is for the coordinator, where we see minimum configuration of 4 vCore up to 96 vCore could be the size of your coordinator. And again, similar ways, like you can see the storage going up to 16 terabytes on a multi-node setup. And at the same time, like if you don't want to modify any configuration on the coordinator, you just want to scale your workers, then all these 3 nodes will be scaled to a common configuration, whatever we choose here, and then even the storage. And just whether you want to have a HA node enabled or not is up to us. So let's say if we enable the HA and we save this, once we are done with this, we just like Postgres version, always we would recommend to go with the latest one. So choose the version, provide a name, like any password to your, give your cluster name here, unique name to it. Yes, name was okay. Okay, so this ways, and we can choose to go with a different region, like whatever region we want to host this in. Just choose the region. Resource group, of course, I didn't do that. So, like effectively, what we have to do is fill this form with all those details, and then move to networking piece. Just if you want to like have the private access enabled to it. You just choose the private access enabled and then add your private endpoint. And like once I'll just choose the public access. uh, I'll just add this as I'm all this is not recommended, but I'm just doing this for the demo purpose, where I'm just trying to tell that yeah, I'm opening up access to everything on the internet. And then I'll just go next, define any tags you want, do the review and create, and yeah, we are
Okay.
done here. At the moment the basics is showing this because I have not chosen the uh,
Sure.
subscription and resource group. So once all of this is like done, we can just hit review and create. uh, it takes around like little over 5 minutes. So um, I won't be provisioning this. I'm just going through this
Okay.
already provisioned node. And now we can see this is one of the nodes where we see a coordinator existing here with two different worker nodes. It has Postgres version 15. It is on Postgres 15 version, East US region. Worker nodes being on this configuration, while coordinator node is of this configuration, right? It defines the availability zone as well. So all of them are on a common availability zone as of now. And by default, we can the HA node will automatically be in a different AZ. So we don't have to take care of that. And then other than that, I would say it would be like ideal to like go here. Uh, there is a well integrated pSQL shell. So to learn more around this and do a hands-on, it's better to like go here. And there are some videos apart from this, like apart from that, if I go back, like launch quick start, so this kind of like gives you a view of like guides you to the process, makes you aware by showing you a sample schema, talks how distribution of table works. Then you can try out the loading of data, query this data. So it's kind of like gives you a complete overview of the service and like provides you enough insights on to learn about the product.
Well, so
Okay.
I guess there is another question that came up right now. Can we connect directly to the work node?
We can. There is an alternative option where with enabling your configurations to allow your connections directly to the workers, you can do that. But the drivers needs to take care of like making these calls to the individual worker nodes. There is no
Okay,
load balancer at the moment which would help you like automatically redirect these queries to different nodes. So that's something application has to take care of.
got it.
Yeah.
Thanks, Avijit. I think thanks for answering all the questions and thanks for this great session. Before I close, audience, make sure to subscribe the channel and please provide feedback if you want to hear about a particular topic or want to present in this particular forum. We will meet again in a couple of weeks. Next time, we will be talking about throttling on Cosmos DB, which is an interesting topic, and most of the customers would be, uh, yeah, excited about that particular topic. We will go live in another uh, couple of weeks with a special guest on 5th of April. Make sure to join. And thanks, Avijit, and thanks everyone for joining. Please, yeah, stay in touch.